Assalamu alaikum. Welcome to my lecture series in high school chemistry. In today's episode, we analyze a given equation of a chemical reaction and identify the reactant in excess and the limiting reagent. Using ratio and proportion, we shall determine the amount of moles of the excess reactant needed to react with a given moles of the limiting reagent. So just hang on, watch and learn. The question is, given the reaction, 2 moles of ammonia reacts with 3 moles of cupric oxide to produce the products nitrogen gas plus or 1 mole nitrogen gas plus 3 moles of copper and 3 moles of water. Question letter E, what is the limiting reagent for the reaction between 3 moles of ammonia and 5 moles of cupric oxide? Question letter B, calculate the amount of cupric oxide needed to react with 3 moles of ammonia. All right, so the first thing that you have to do is to check if the chemical reaction equation is already balanced. All right, so uh, in checking whether the equation is already balanced, we just count the number of atoms of each type of element, both on the reactant side and on the product side. All right. So here in this equation, it means that there are uh, 2 atoms of nitrogen on the reactant side, and that's also true for the product side. There are 2 nitrogen atoms. Now, for hydrogen, this means that there are 6 hydrogen atoms on the left side and 6 hydrogen atoms as well on the right side. All right. Now, for copper, there are 3. All right, on both sides. And lastly, there are also 3 oxygen atoms on the reactant side, and that's true also for the number of oxygen atoms on the product side. So that means this chemical equation is already balanced. All right, and then we emphasize that uh, based on this balanced equation, there are 2 moles of ammonia that can react with 3 moles of cupric oxide. All right, and step 1 in our solution is to find the substance in excess. All right, so between ammonia and cupric oxide, okay, we have to identify which substance is in excess. And then, step 2, we will use the concept of ratio and proportion in calculating the amount of cupric oxide that is needed to react with 3 moles of ammonia. All right. Our ratio and proportion equation goes like this. 2 moles of ammonia over 3 moles of cupric oxide equals 3 moles of ammonia, all right, over X mole of cupric oxide. So, um, the amount of moles of ammonia used in the chemical reaction is exactly 3 moles. And we ask how many moles of cupric oxide is needed. Therefore, our target variable X is the amount of moles of cupric oxide. Isolating the variable X, we get X equals 3 moles of cupric oxide times 3 moles of ammonia divided by 2 moles of ammonia. All right? So moles ammonia gets cancelled. So we get the value of X equal to 4.5 moles of cupric oxide. All right? So this is the number of moles of cupric oxide needed to react with exactly 3 moles of ammonia. And we say that um, cupric oxide is the substance in excess. Why is this so? If you refer to question letter E, you will note that 5 moles of cupric oxide is given. And in this step 2, all right, we found out that only 4.5 moles of cupric oxide, all right, is needed to react with 3 moles of ammonia, all right. Um, this means that out of the 5 moles of cupric oxide used in the chemical reaction, there is an excess of 0.5 mole, all right, that remains and unable to participate in the chemical reaction, all right. That's why we are able to say that cupric oxide is the substance in excess, and so therefore uh, ammonia would be the limiting reagent in this chemical reaction. So that concludes my presentation for this topic. Till the next episode, mabuhay, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.